Welcome to lesson 3, problem number 2, where we are solving compound inequalities. Okay, let's get started with the first problem, 2a, and we're going to start by trying to get the x, the variable, by itself. We're going to do that by subtracting 12, but we have to do it from every one of the three sections. So now we're going to get negative 20 is less than 5x, which is less than or equal to 20. We have to get x alone, so we're going to divide every one of our three sections by a positive 5. And just like that, we have negative 4 is less than x, which is less than or equal to positive 4. So this inequality is really the same as saying negative 4 is less than x, which is less than or equal to positive 4, but we can also say negative 4 is less than x and x is less than or equal to 4. So this is what's considered an and, which typically means we are going to shade in the middle. So I'm going to put an open circle at negative 4. I'm going to put a closed circle at positive 4 based on the less than, and then the less than or equal to gets the closed circle. And those shaded points are every single value that would work in this inequality. All right, let's move on to the next one. All right, so this is also an and, so we're most likely going to shade in between two x values. So let's kind of start here with subtracting 2 from both sides, and we simply get negative 15 is less than negative 3x. Divide both sides by negative 3. And on the left, we get 5. But don't forget that we divide it by a negative. So we have to flip our less than greater than sign. In this case, we get 5 is greater than x. Personally, I like to write it as x is less than 5. But it means exactly the same as 5 is greater than x. And if you're not sure why that's true, stop the video and think about that for a minute to make sure the logic behind that makes sense. All right, let's go to the next one. And this time we're going to multiply everything through by 2 because I love to eliminate those fractions and make our lives much easier. That 2 is going to distribute to every term in that inequality. 2 times 1/2 is x. And again, if you're not sure why 2 times 1/2 x is just x, stop the video and review your multiplication of fractions. Okay, the 2 times the 2 gives us a plus 4 is greater than 2. This is going to be a nice one because we're going to just get x alone really quickly. X is greater than negative 2. So now we have these two different portions, and I'm going to re-enter the word and. You know what, though? I'm going to make that a little bit neater and make that and really clear. So x is less than 5 and x is greater than negative 2. Now notice that in this case, both of our circles are going to be open, not shaded in, because it's just x is greater than negative 2, so that's an open circle. X is less than 5, that's also an open circle, and we're shading in between. Those are the only values that work in both the left-hand inequality and the right-hand inequality. Okay, let's go to the ors. Ors typically shade to the left and to the right on the number line, but let's see what happens here. Okay, so C, we're going to subtract 8 from both sides. 7x is less than 0. Divide both sides by 7. Don't forget, 0 divided by anything is simply 0. So, we have x is less than 0. Okay, so already I can go to 0 and put an open circle and shade to the left because x is less than 0. Or meaning if the value works in this inequality or the other one, we're in good shape and it is a solution. So the next one, we're going to add 1 to both sides and we get 5x is greater than or equal to 10. Divide both sides by 5 and we're going to get x is greater than or equal to 2. So we go to 2, put a solid circle this time because of the or equal to, and shade to the right. Every one of those shaded portions works either in the left hand or the right hand inequality in C. It doesn't have to work in both. It's either or. Or means it can, as long as it works in one of the inequalities, we're good to go and we have a solution. Okay, let's go to D. I'm going to distribute here. So we're going to get 11x plus 11 is less than 22. So all I did so far was distribute. okay? Or 5x minus 3, I'm just going to rewrite that just so we have them both in the same spot, is greater than or equal to 27. Okay, I'm going to work on the left inequality first. Subtract 11, subtract 11. 11x is less than 11. Divide both sides by 11, and we simply get x is less than 1. So I'm going to go to 1. I'm going to make that an open circle and shade to the left because x is all the values less than 1. Or we can add the 3, and get 5x is greater than or equal to 30. Divide by 5, and notice I'm always using that fraction line for division. X is greater than or equal to 6. So here's my value at 6 with a closed circle, and I'm shading to the right. And every shaded value works in either the left-hand inequality or the right one. Great job.